Hello, friends. This is Jim here with Science Talk, and this is part 4 of a summary of the weather conditions in Alaska since basically the summer into fall and early winter. So I want to pick up where I left off in the last video. So this is update 3, meaning part 4. And I want to first, and I really should have done this at the very outset. It occurred to me, I'm mentioning all these acronyms and just throwing all this stuff around, and then on some of the slides there, you see these various acronyms. I thought I'd just explain them here so you have them for reference. And if it helps, if you wanted to go back and look at previous videos, segments I've done on this, you will now have a better idea. So ACCAP is the Alaska Center for Climate and Assessment Policy. You have ERST, ESRL, NOAA, NSIDC, OISST, excuse me, and biomass. It sounds like biomass is biomass. That's the Pan-Arctic Ice Ocean Modeling Assimilation System. There's a URL. Very good organization doing excellent research, a very good website, a lot of detailed information. If you're so inclined, you can go check it out, bookmark it perhaps, what have you. So there you have it. Earth System Research Lab is affiliated with NOAA. NOAA, of course, is National Oceanic and Pacific Administration, NOAA.gov. NSIDC, National Snow Ice Data Center, located in Boulder, Colorado. NSIDC.org is their website. Okay, so with that out of the way, let's proceed. September warmth broke records in many locations worldwide, according to the GHC and Volume 4 data. Okay, and basically of 5,640 sites with at least 30 years of data, 17% were at least 2 standard deviations above the 81 to 2010 normal. 11% for non-US sites. So red is record high, blue is record low. And when you look at this, where do you see the blue? You see the blue pretty much like right there between Denmark and Sweden, and then somewhere over here, one of the stands in the Pacific Northwest. Interesting. Why is that? PDO? EDO? Pacific Decadal Oscillation. But look at the U.S. here. It's just the U.S. was cooking. This is the North Slope of Alaska. It's cooking, right? You just see where it's just hot. That's Hawaii over here. And you got some, down in Australia. So it was just hot around the world for September 2019. 2-meter temperature anomaly. This is for, right? World Climate Service, again, they do a lot of work here. They're looking at sea surface temperature, and 2-meter temperature means that, when they measure sea surface temperature, what they're talking about here is basically the average depth to 2 meters. So it's not like they take the thermometer bulb and put it right at the exact interface with the air. No, they go about 2 meters down. And what do we see? It's just whoppingly hot. Here's the Chuck GC. See how warm that is? Okay. So they're looking at they're looking at all the surfaces, land and oceanic, aquatic, what have you. A little cool down in Antarctica, September 2019. Now remember, Southern Hemisphere, okay, they're coming out of winter in September. So it's coming into spring, so they still have an effect of the winter. That's why you see Antarctica so cold. They're having winter. They're coming out of it. They're still in it. Okay. So we see it's very warm in the northern hemisphere. Again, a couple little isolated cool spots that correlates with the previous slide. And World Climate Service provided this graphic. Global sea surface temperature in September above the 20th century average for 520th consecutive month. Now, this little reference, also, it's not sunspots. Okay. Look at the gentleman who provided that, Brian Brett Schneider. That's his dig at the people who keep saying it's sunspots that causing the global warming. No. There's been a number of studies that have looked at that very question, and the studies have basically come to the conclusion that sunspot is not a significant contributor to the climate signal that's being observed. So the sunspots is this green line here. As you see, it's cycled, and there's zero correlation with what temperature is going on. It doesn't matter if sunspot activity is high or low, it's just warming. Okay, so this is going from 1900 to 2018, 2019, right, through September 2019. So there you have it. Cooler at the first half of the century, and it starts warming up. We got a little bit of warm spell, cool spell, warm spell, cool spell, right? And then starting in about the 70s, it's just been warm. Do you see, this is 1977 right there. Do you see any average global sea surface temperature cooler than the average? No. All the deviations are warmer and significantly warmer, right? This is in degrees Celsius. They're basically talking almost a degree warmer. Now, this is going through, I showed you in the previous video that it was closer to 2 degrees C. That's because of the years that they looked at. They didn't go far back as 1900. When you factor this in here, yeah, it brings down the average a little bit, but that shows you how significant this increase is. So this study, this graphic here, there's a lot of information here telling how much warmer the oceans are. And remember, specific heat takes a lot more energy to heat up water than does the air. If I have the same given volume of water versus same given volume of air, and I want to heat up the water 1 degree C, the air 1 degree C, it takes considerably more energy to do that for the water than for the air. So as I explained in the earlier video, that indicates how much energy the oceans have absorbed, saving out bacon for the moment until the warm waters can't absorb any more CO2 and starts outgassing it. So back to Alaska's North Slope. So again, I give you this kind of give you a perspective worldwide, right? Everything's just, most part is just really warm in the Northern Hemisphere. And you notice it's warmest up in the Arctic. And what goes in the Arctic starts driving the rest of the planet. So looking at this slide here, the 12-month average running temperature for Alaska's North Slope is blown through the roof. Now more than 4 degrees C warmer is typical in the 70s. We see it here. This is the North Slope, 12-month running mean temperature. What that means is a temperature every day of the year, and they average it, and then they give you an average for the year. Okay, 12-month running. But what that means is, okay, if you say you're in January, so you measure the previous, let's say let's start with February. You're in February, so you measure the previous January and 12 months earlier. Then when you come to March, you start with February, go to 12 months earlier, and so on. That's what's meant by running average. So if I wanted to know a 3-month running average, so say I go June, July, August, okay, I get an average. Then I go July, August, September, October, etc. So that's usually meant when they say running mean temperatures. And as you can see here, here's your trend line, right? You're familiar with this graph now. It just goes up. Look at all the yellow, orange, red dots. And so this is degrees Fahrenheit here, degrees C here. Now remember, if you're less than 0 C, that means you're negative C. So we're going from basically 11 to 7, 4 degrees. That's significant warming. Significant warming. Okay. So, bluffs eroding, ice cellars thawing and flooding, archaeological sites and cultural heritage thawing and rotting, roads like washboards or washed away, fill collapsing around pilings. That's Dr. Ann Jensen. She's an archaeologist who works on the North Slope. And then Rick Tolan states, it's a wrap on the greatest thaw season of record at Utqiagvik, means more accumulated warmth in 2019 than any in the known past. Summer heat is the primary driver for permafrost warming, thawing, and active layer deepening. As I explained in the last video, as you warm the active layer, which is the seasonal layer that thaws and then refreezes, that's getting deeper, which means that you're thawing more and more of the permafrost, releasing more methane. So if you thaw more permafrost, you're making the active layer thicker, which means it goes deeper. That means you have to go down deeper into the ground before you hit solid frozen, permanently frozen, take your axe and go thunk, okay, there it is. So this also presents issues, and I did a video some time ago talking about what thawing permafrost means to the infrastructure of any civilization, crumbling roads, sinking houses, that kind of stuff. So here's the accumulated thaw degree days, like I did in the previous video, the smooth average, right? And you just see how it's warming. So there you have that. It's getting warmer. The Arctic is really warming, and permafrost is thawing. And when it thaws, it creates all these issues that Dr. Jensen has mentioned. September, St. Paul Island in the central Bering Sea, tied with 2016 as the warmest September of record, largely reflecting the very warm sea surface temperature in the Bering. 4 to 10 warmest Septembers in the past 105 years have occurred since 2014. And you see it right here. Again, smooth average, right? By now, you probably know how to read these graphs, which is good. I won't spend a lot of time discussing them. The 10 warmest, 10 coldest, running average through here, but here's your 4 warmest. This is definitely a trend. Utqiagvik average temperature for October 2019 at not quite -2°C makes this the second warmest October in the past century. Loss of October sea ice near Utqiagvik and impact on temperature is the most dramatic example of abrupt climate change. Okay, so no longer saying weather, abrupt climate change. Remember, climate is long-term average weather. Okay. Again, 10 warmest water. Now, what they decided to do here, they're showing what the error average is showing. So they're not showing a changing average. They're showing an error average. So this would be above average. This would be below average. This is what they're talking about, the abrupt change, because now starting in the early 2000s, this is a dramatic jump, collapse of year-to-year variability right here. So look at this jump here, going from 15 to basically 24. That's a 9-degree jump. Okay, that's in Fahrenheit. If you look at it in Celsius, it's about 5. That's a dramatic jump. It's an abrupt snap. This is the barrel. That's October average temperature. It's not supposed to be this warm in October in Barrow. I've been to Barrow in the October, November, December. Yeah, it's a lot cooler. Oh, I like Rick. In today's least surprising news, his little snide, he's a funny guy. The July through September 2019 average temperatures for Alaska is the highest of record since 1925, according to NOAA Ansel climate analysis. So it was 3.9 degrees Fahrenheit, 2.1 Celsius above the 20th century average, easily exceeding 97 in 2007. And you can see it indicated 2019, and you can find 2007 and 1997. That was our 1997, 2007. Again, here's your trend. July through September, average temperature, statewide. That's the whole state, from Barrow to Ketchikan, the entire state. This statewide daily temperature index distills temperature departures from around Alaska down to a single number between -10 and +10, with 0 being normal. Thus far in 2019, 90% of days were warmer than normal. This is not fine. So you can see they go January 1st, January 16th, February 1st, February 14th. So they basically do a beginning and the middle of each month, beginning and middle of each month. So basically what they're doing like a running 15 day average or so. And then they plot it. So since January 1, 286 days above normal, 33 below normal, right? So you start counting these dots, you get 33. But look at this, all above. Black line in the middle here is normal. Most of them are above. January, okay, so you had a cool January. Okay, February had a little cool, quick little cool spell in February. Might have been a storm event over, let's see, April. I think there was a storm event. I seem to remember we're getting a snowstorm in mid-April. And then this could be in August, rain. So chances are where you see where it's cool, it's probably some sort of a significant precipitation event. And or it actually had the cold temperatures it's supposed to have for that time of year. These little dots that you see here on the state of Alaska are the stations that collect the data. That's what those little dots are. Based on 25 statewide locations, okay, and this is updated through November 15 of 2019. I'm recording this November 22nd. So this is just a week ago. As Rick said, this is not fine. Over the last 12 months, the average Alaska statewide temperatures is 32.7 degrees F, which is about 0.45 C. This is the highest value for the 25 to present time period using NOAA and CEI statewide values. So starting at 25 up to 2019, temperature degrees, the variations are expected to be seasonal, but if you start looking from here, there's definitely a trend going up. This little spot from 2010 to 2013 is due to a La Nina event, as well as the PDO being in a negative phase, which usually indicates a cooler Alaska. But it's still trending above normal. If you look at the species, again, starting from the 70s, put a regression line in here, slope of the regression line will be positive. Just to give you an idea, the average temperature year-round for Alaska, historically, okay, they're recording at 32.7 degrees F. Okay, average temperature in degrees Fahrenheit, historically for the entire state of Alaska for the entire year, historically has been 28 to 29 degrees Fahrenheit, i.e., below freezing. That takes into account the southeast panhandle, which has temperate zones, now where the average temperature is above freezing. Think about that. Okay, here's the 5-year, 60-month running average temperature. It's never been as high as it is now, 2.8 degrees C above the 20th century average, getting close to freezing. Okay. So, depending which data set you look at, some will, come up with, NOAA says the 32.7, okay. Another NOAA, looking at 5-year running, 5-year running average versus 12 months. So this is not a 12-month running average. So if you look at running the averages over 12 months versus over 5 months, it depends how much information you can tease out. So the 20th century average is supposed to be this green line, horizontal line here. And you notice it's about minus 3.4 C, about 26. Okay. Some will say 26, some will say 27, some will say 28, some will say 29. Depends on the analysis. But the point is the average temperature for Alaska for the entire year, for the entire state, is below freezing. It's in the 20s. Now it's no longer the case. Now it's approaching freezing, at freezing, or slightly above freezing, depending on which analysis you want to use. If you want to, depends how much you want to show as a trend. Do you want to show 5-year running average, 12-year running average, what have you, or 12-month, whatever you want to do. Okay? This is the 12-month. A 12-month will tease out more details than a 60-month. So by teasing out, by doing 12-month, you can tease out the fact that, we're now just above freezing. If you were to do a 120-month 10-year average, you'll probably arrive at a lower number. It all depends what you wish to accomplish in your analysis. So if you take the most conservative estimate, this is a more conservative estimate, it's still telling us that we're warming. Say this is 31. That's 5 degrees Fahrenheit warmer. Right? If you look at the previous one, they don't indicate the average, but throw in an extra almost 2 degrees, because a 12-month 1-year running average can tease out more variability. Because this one goes from 1925, so they're both starting from basically the same time frame, 1925, 1930 or so, and it shows what's going on. Now, let's check in and see how the Alaska statewide temperature index looked for the last 90 days. So August 23rd, 2019 and November 20th, 2019. This is just 2 days ago, folks. And what do we see? Well, let's see. We have 1, 2, 3, 4. We have 5 days where it's just slightly cooler than the average. Otherwise, well above average. 30-day average is shown as the black line. So now let's go through this. A value of +1 means that the day is warmer than 10% of all above normal days. The value of +8 means the day is warmer than 80% of all above normal days, etc. The opposite is true of negative numbers. If you had -1, that means the day is cooler than 10% of all above days. So in other words, if you see a value of, let's just take the 80%, +8, that means only 20% of days is warmer than that one day. So in other words, when I look at this one here, right, that's +1, so that's 10%. That means 90% of days was warmer than this. This falls in the 10th percentile. Here's a +10 is basically 100%, meaning that it's like the warmest. This is setting a record high temperature. Let's take a look. Here's a +8, +8.1. That means it's like 20% that were warmer than that day. That's kind of how you can look at this graph. And again, here are the reporting stations, 25 reporting stations. What is this telling us? It's friggin' warm. This is what it's telling us. Very clear what the trend is. Temperatures above normal for this 3-month period. So Let's look at the Northwest Canada Quarterly Outlook with a review of the eventful summer 2019 and a look ahead to the rest of 2019 is now online at this URL. Alaska, Northwestern Canada, Utqiagvik, 73 Fahrenheit, 22.8 C on June 20th was a monthly record high temperature. Denali National Park headquarters, July 24th, August 23 saw the greatest 31-day precipitation total on record, nearly 11 inches. Holy crapola. Anchorage, each summer month of June, July, and August was the warmest on record, with 90 degrees at minimum. I think it was 94 that was hit in June. Anchorage never gets the 90 degrees. It's the first time ever 90 degrees was ever recorded in Anchorage. By the way, the hottest temperature ever recorded in Alaska was at a little village called Fort Yukon, which is located right there where the cursor is, because that's, hang on, I got to move it up a bit. Where's the cursor go? Right there. Okay. That's the Yukon River. That's where the Yukon River reaches its most furthest northern point before heading southwest towards the Bering Sea. And the temperature recorded there was either 99 degrees Fahrenheit, 100 degrees Fahrenheit, depending which record or which data you want to look at. So Anchorage came close to the highest temperature ever recorded in Alaska. Juneau, 45 days with a daily max temperature of 70 degrees Fahrenheit, the most in any year. Fort Liard and Fort Nelson, that's down in the BC, both locations were colder than normal by 1.8 degrees Fahrenheit, which is 1 degree C. They're also wetter than normal, which is why it was probably cooler. So they receive 125%, 128% of normal precipitation. Whitehorse, warmer than normal by about 1 degree C, 0.9. Wetter also. Norman Wells, second coldest summer on record with an average temperature of 54.1 Fahrenheit. Didn't even know there was a place called Norman Wells, to be honest. Never heard of it. So why these swing from like hot, cold, whatever? Okay. You have more open water here. The Chukchi was really warm. And the flow brings it this way. The Beaufort was also warmer, but airflow does not quite bring it to this way. And you have to take into account what the Arctic Oscillation, what the Arctic Dipole is doing. Inuvik, this is the town I used to go to as a staging point to drive up to. This is the Mackenzie River Delta. Used to drive up there and along the way on the Mackenzie River, take ice core samples, and then get out onto the ice that way, in addition to going to Point Barrow and out to the Chukchi. So I've kind of traversed this whole region here, working with the sea ice. And the Mackenzie River, back in the day, would freeze solid, something like 6 meters thick at least or so. And you've probably seen the show Ice Road Truckers. Yeah, I'm driving on the ice on the frozen river there, and there's these the big rigs going by. I used to drive the big rigs. Anyway, so this is kind of a little summary of what's going on for this region. First half of November brought more or at near record warmth to southern Alaska, also along the North Slope coast, thanks to no or low sea ice. Some low elevation areas, I'm going to just move myself out of the way here for a bit. Some low elevation areas in western Alaska still had bare ground and record low snow in Anchorage. Okay, do that. So the first half of November 2019, weather and climate highlight. Okay, we already know Utqiagvik was warmest. Chukchi Sea average ice extent lowest of record, 18% of the 30-year average. Toolik Lake, site of a long-term ecological research station. So, they're getting data there. Lowest official temperature of minus 27 degrees. Well, that had to have been in November. Yeah, that's the lowest, coldest November. Tok had the second highest seasonal snowfall, almost a yard. Talkeetna was the warmest. Anchorage the warmest. King Salmon the warmest. Cold Bay the warmest. Kodiak the warmest. Homer's the warmest. Cordova, Sitka, Ketchikan, all the warmest. Nome Head, blowing crap. Nome is always blowing crap. Excuse me. And if you recall from the previous video, I talked about how the Southwest and Central Alaska was really the hottest, biggest deviation, the hottest on record. And it's obviously continuing into the first half of November. Okay, let's now go to sea surface temperatures. So they remain above the 71 to 2000 average. Over the past month, departures have mostly increased in the northern Bering Sea, decreased in the Gulf of Alaska. In other words, it's getting warmer in the northern Bering Sea, cooling down a little bit in the Gulf of Alaska. And you can see that, right? Here's that little darker, I don't know what we call that color, and it's lighter here, right? So here is about 2 to 3 above average, and now we're getting to for here to 3 to 4 above average. And that's basically what's going on here. It's still hot, very hot off is Utqiagvik, is the Point Barrow. So it's still pretty much hot here. This is the Chukchi, still considerably warm in the Chukchi. And that's September 27th to October 3rd. October 11th to October 17th. For some reason, I don't have the previous week. But I think you can quickly fill in what happened in that week there. Right now, this is almost at normal temperatures here in the Gulf of Alaska. It's still above normal here. And this is approaching basically the middle of October, and it's still considerably warmer above average. Now, keep in mind, with specific heat, yes, it takes longer to heat up the water, but it also takes longer to cool down. Actual temperatures, which are the dashed lines, that's these guys here, still well above freezing. Northern Chukchi, Western Beaufort Seas. Sea ice return is weeks away. We should already be having sea ice, not waiting for it to appear. And of course, this is going to affect the natives when they go out on their seasonal hunts. They're depending on the ice being there. If they have to go out in a boat and you have storms up there, you're going to lose a lot of people. Right? And by now, you know how to read and understand this chart here. This is Rick's tweet giving high praise to Brian. You know him through his groundbreaking analysis of regional pie preferences. It's a little kind of in-house joke. But Climatologist 49, that's Brian Brett Schneider's Twitter handle, also creates innovative tools to extract even more climate information from long-standing data sets, like the sea surface temperature ranking from the NOAA ESRL, so you now know what that acronym means, OISST, so you know what the OISST acronym stands for. Sea surface temperature rankings from May through October 2019. Record warmest, much above normal. That pretty much, and then this here is above normal. So pretty much everything that you see in the Bering Sea, the Gulf of Alaska, through the Bering Strait, into the Chukchi, and into the Western Beaufort is above normal to record warm. That's basically what this graph tells you. And here, it's normal. And it gets record warmth there again. This is a Kotzebue Sound, kind of really warm there. So it's a nice piece of data analysis here by Brian. Let's check and see how many of the last 12 months had ocean sea surface temperatures above normal in the Gulf of Alaska and Bering Sea. I think this should come as no surprise that it was above normal. Analysis of all months between November 2018 and October 2019, global average is 8.1 out of 12 months. University of Alaska Fairbanks, right? Data source based on a total of 12 possible months using the 83 to 2010 climate normal period. So in other words, we see this red here, that means every single month was above normal. So the light blue is 6 months above normal. That's here. But when you see the red and the green and the yellow, it's the majority of the months is above normal. So that's the information you can take away from there. As far as you notice that they don't do the analysis for pretty much right up against the coast, and that's a function of where you have oceanic buoys collecting data, that kind of stuff, or satellite imagery, looking at the infrared signal, what have you. So you got a couple spots where it was maybe 4 or 5 months, 5 or 6 months cooler. 4 to 5 to 6 months only where it was warmer than normal. But still, this is the Arctic. But when you get to this location, you can see that for what the majority of what's represented here in the Arctic Ocean aspect, it was still more than 6 months above normal. 6 months of warmer than usual temperatures. I don't really see any purple telling me, telling only just 1 month. I don't really see any. So this is telling us that the oceanic waters are really warm. Now, keep in mind, when you actually form the ice, the sea surface temperature is going to cool down. It has to for the water to freeze. Arctic sea ice extent for September averaged 4.3 million square kilometers, third lowest in the 41-year continuous satellite record. Okay, so this is the extent in square kilometers. That's how much of the surface of the ocean was covered in sea ice. Okay? And this is looking at the month of September over 40 years. So starting in 79, going to 2019, you see a very clear trend that is decreasing whoppingly. And again, this is NSIDC data. You can go to that website, that URL, to see further information. Chukchi sea ice extent, again from the NSIDC data, is the lowest of record for this point in the season, but it's not a one-off. The typical mid-October extent has decreased greater than 80% in less than 40 years. Let me repeat that. The typical mid-October extent has decreased greater than 80% in less than 40 years. Incredibly rapid change. Okay? There you see a smooth median. Look at this, right? See, look at how, you got two peaks here going into the greens here. It's diving down. Chukchi Sea has never had anywhere near this little sea ice so late in the autumn, not even close. All this open water is a heating pad under the Arctic atmosphere, pumping heat into the polar night, hence a warmer air temperature. And pumping heat, latent heat energy, means more precipitation and lots of it. No other way to put it. This is bad. This is Rick Pullman's words. Here's 2019. So late in the autumn. There it is. So late in the autumn. That's the minimal. That's a record low. So now, as you go through my videos, you can see how this green line has been progressing through the series of videos. Okay, so we reached the minimum extent about September 17, 18 or so, and now it is starting to form, but it's still not even close, right? Here's the ice, still not approaching, still not freezing the Chukchi. Sea ice growth from the past weeks has been steady, but minimal in Beaufort. Still no significant ice close to Alaska. Right? So that's this here, right? No ice here, starting to form here in the Beaufort, eastern Beaufort, right? So this is combined daily ice extent 79 through 2019 average. So this is the median for the time period in question. This is 2018. This is 2019, and this is updated through October 12th. We go a little further along, updated through October 26th. Sea ice extent is increasing as water temps cool, but still lowest on record. Strong storm and warmer air moving into the region is likely to slow sea ice growth. Because you get turbulence, you start churning up the surface water, a little harder to freeze it. And you can see it's still steadily increasing. 2012 is kind of a record extent, but if you look at it, the melting started later. The melting started earlier. So it was warm. It really rapidly reached a low extent, but it also started freezing up sooner and faster. Let me look at that. Okay, this is showing 2018. This is now showing 2012 in red. That was the record lowest sea ice extent on average ever. But it started later, started melting later. It just rapidly melted, but then it started freezing up. It kind of like bottomed out before, then it rapidly started freezing up. And then, as you can see, it's quickly froze over. There's another graphic through this is, I think, biomass data. No, this is NSIDC data. Yeah, NSIDC. Very slow ice growth continuing in Chukchi. 2019 remains a record low and outlier relative to the satellite era record. 2012 could be a close second. This year's early spring/summer sea ice melt out is likely a contributing factor. More solar absorption gives you warmer ocean waters. That's a quote from Zach Labe, who presented this. You can still see how it's just wallowing around down here. And now we're going through November 16th. So now we're comparing it to 2017. Again, keep in mind that this melted or started melting earlier. Pretty close, comparable, minimal extent. But now look at this difference here. Okay, so on November 16th, we're about 80,000 square kilometers. In 2017, for that same day, it's about 300,000 square kilometers, an approximate difference of 120,000 square kilometers difference in sea ice extent. Now, if you look at this here, you can see that the ice is starting to close in. The Beaufort Sea now is covered in sea ice. Chukchi Sea still not yet. Now let's look at the volume of sea ice, not just the surface area that's covered, the volume. This is our non-feedback heat sink that's disappearing, and it absorbs 86 times more energy when it melts. That means the same amount of energy will warm the water 86 degrees C without ice to melt and keep it at 0 C. Modeled reconstruction of October Arctic sea ice volume since 1901, comparison between biomass 20C and biomass data sets now updated through October 2019. Exactly. So what this basically telling us is that sea ice thickness is also decreasing. Multi-year ice occurrence is decreasing. Now, this little reference about 86 times more energy. If I have a kilogram of water and I want to heat that kilogram of water 1 degree C, it takes approximately 4 kilojoules of energy to accomplish that. If I have 1 kilogram of ice and I wish to melt it, in other words, change its state, its physical state from solid to liquid, to melt that 1 kilogram of ice takes approximately 80 kilojoules of energy. In other words, about 20 times more energy than to merely heat it in its already liquid state 1 degree more. Now think about Antarctica. Think about Greenland, all that ice melt. Now start thinking about the volume and how many kilograms of ice is melting. And now give you an idea of how much energy input into the system is occurring. It is extremely alarming. And then once you turn into liquid, well, then all that energy that would have been needed to be absorbed by the ice to melt it would now just simply heat the water up. So this is extremely alarming. It's very troubling information here. But as you can see here, the trend is clearly a decrease in the volume. And this is by 1,000 cubic kilometers. I'll say it again. Over the last 40 years, the sea ice on average freezes later in the year, melts early in the year. The extent is less. How much square area it covers is less. The volume is decreasing. The occurrence of multi-year ice is decreasing. That's what's going on. Sea ice extent from the NSIDC data. Okay. So this is looking compared with the same date the previous 4 years. Except for Kotzebue Sound, sea ice extent is in worse shape in 2019. So starting 2015, that's the sea ice extent here. Right, here's the Chukchi Sea, but you can still, Beaufort's totally frozen. There's ice next to shore. Okay. Look at 2016. This area, the Chukchi, a little larger. The extent of the ice close to shore is not as much. A little bit of open water right here. Look at 2017. More open water. This is November 18th, right? Beaufort's still frozen. Very little ice next to shore. Now, 2017. 2018, okay, was a little bit cooler. There was more ice. Now look at 2019. Big, huge opening here. It is Kotzebue Sound. So that's kind of interesting what's going on there. And this here, right? This here is called Norton Sound. Some of the Iditarod mushes will try to reduce their time by cutting across the sea ice during the Iditarod. Well, that strategy is becoming less and less palatable given the situation with sea ice for the past few years. So this is showing you how 2018 was kind of a cool year, even though we saw in the previous slides how the extent was less. But what that's telling us is that the freeze up was occurring at a faster rate. That's a nice, interesting trend. Nice in quotes. And just to courtesy of climatereanalyzer.org, Climate Change Institute, University of Maine, Kevin Pluck is the gentleman who put this together. And what this is showing on this side is sea surface temperatures, this side ice extent. And then it threw in 1999 for comparisons. So you can see the very warm sea surface temperatures here in the Beaufort Chukchi Seas. And not surprisingly, that leads to open waters in the Chukchi Sea where you would expect to see ice. Compare that to 1999. That's pretty much ice there. So it's got the world was about 0.4 degrees C warmer, 0.5 in the tropics, northern hemisphere about 0.7 degrees C, southern hemisphere at 0, basically stayed the same. Arctic was 2.3 C above normal, and Antarctica is 0.4 degrees C above normal. That's interesting in Antarctica. And that's for a specific date, November 12th. So even in Antarctica, coming into the springtime, it's not have a tad warm spring. So I thought this is an interesting thing to compare and contrast. It's kind of cool in the midsection of the U.S. there. Well, I know let's think about the changing jet stream pattern becoming going from zonal to more meridional. So when it dips down, it brings the cool Arctic air with it. So kind of a shorter video here. I'm sure you're probably thankful for that. But again, this is the same closing credits I used in the prior videos here. Just want to acknowledge the tireless work of these two gentlemen and others that I indicated here. Uh, they don't have to, I mean, this is part of their work. They don't have to take the time to just present this, you know, to actually disseminate this to the general public. So this is really excellent of them that they're doing this to share with us what's going on. And they're both pretty cool guys. So that's the latest on what's going on with the weather/climate situation up here in the Arctic. Thank you for your time. Until we talk again. Hey folks, it's a reminder to please share my videos with others and to also please tell others of my channel. Please subscribe and don't forget to hit the bell so that you receive notifications when I upload new videos. I also hope that you will consider supporting the work that I do and supporting this channel by becoming a patron at patreon.com. Details in the description box below. Thank you for your support.